Okay, class. On today's agenda, we're going to be discussing circles part 2. We're going to be reviewing some rules and some parts of circles which we've already discussed before in the past. So, we're going to review minor arcs, which we know are arcs that are less than 180 degrees. We're going to review major arcs, which we know are arcs which are more than 180 degrees. And we're also going to review semicircles, which we know are arcs that are made by diameters and are exactly 180 degrees. When we're done reviewing these parts of circles, we're going to learn some new rules. The first rule we're gonna learn today is the arc addition rule. We are also going to learn the congruent arc rule. Then we're going to discuss the diameter and chords collide rule, what happens when diameters and chords collide. And then finally, we're going to learn the two chords in the same circles are the same distance from the center rule. In other words, what happens when two chords are the same distance from the center of a circle. After we're done with that, we are going to work on some exercises on page 607. Then we're going to work on some additional exercises on page 608. And then when you're done working on those, in complete sentences, you're going to answer questions 39 through 46. So your answers for 39 and 46 are going to be numeric, they will be a number, but also in a complete sentence, you're going to have to use one of these three previous rules that we discussed to answer these questions. When we're done with that, we're going to assign some homework, and the homework is going to be on a work page 28, numbers 1 through 27. And in these questions, you will also have to answer some of the questions in full sentences, discussing the rules that we learned today. And then we're going to have a quiz. So let's begin with our review of minor arcs, major arcs, and semicircles. Well, when we're talking about circles, remember that a circle has 360 degrees. Okay? Now, when we look at this diagram of a circle here, there should be certain things that we notice. Well, you probably see this central angle here. And a central angle is an angle whose vertex is at the center of the circle. So if I look at my circle P here, and we know it's the name of this circle is circle P because P is the point in the center, I have an angle that I can make with that vertex, and that angle is APB, or angle PBA. Since the vertex of my angle is at the center of my circle, then this is called a central angle. Now, let's talk about a minor arc. A minor arc is an arc that is less than 180 degrees. So I labeled it in pink, and if you notice, I'm saying that this little arc here, this pink arc, is a minor arc. And here is the symbol for an arc. And notice that here are my two endpoints of my arc, AB, arc AB. Next, on the bottom here, in green, I have a semicircle. And if you notice, I have this section of the circle in green. And a semicircle is an arc that is 180 degrees, or half of a circle. So if you notice here, I can see that this is half my circle. So in green, that is a semicircle. And the definition of a semicircle is that it's an arc whose endpoints are the diameter of the circle. So if you look here, here's a diameter going through my circle, and you can see here in this arc that the endpoints of the diameter are the endpoints of the semicircle. And that's how I know it's a semicircle. That's how I know that this is half of the circle, because the endpoints of this semicircle are the endpoints of the diameter. Okay? And if you notice here, the name of this arc is arc ABC. If you notice, arc ABC. So to name a minor arc, we only need 2 letters. To name a semicircle, we need 3 letters in the order that they're going. A, B, and C. So this is arc ABC or arc CBA. but usually you're going to go in alphabetical order. Next, we have a major arc in blue. And a major arc is more than 180 degrees. So if you notice here in blue, I'm going from here. You notice, by the way, this is the diameter. So you could say that this is also half of the circle from A to C. So that's half the circle. And then notice the blue is going a little bit more further, right? It's going a little bit more than just half the circle. So that's more than half of my circle. And the name of my blue arc, of my major arc, is arc A, C, B. Arc A, C, B. Going in the order of the arc A to C to B. And if you notice, when we're naming a major arc, we also use 3 letters. So when we're naming a minor arc, we use 2 letters. When we're naming a semicircle, we use 3 letters. And when we're naming a major arc, we also use 3 letters. Let's take a look at another circle. Here I have circle H. And you can see here in green that I have a diameter. I know that it's a diameter because its endpoint, I have a semicircle. I'm sorry. Notice in green here, I have a semicircle. I know that it's half of a circle because in this diameter right here, these endpoints of the diameter are also the endpoints of this semicircle here in green. And they were kind enough to write 180 degrees, which we know is half of a circle. So here in green, we have a semicircle. I can see that its endpoints are a diameter. But now let's discuss something a little bit more important. Let's discuss this central angle here and the arc that it creates. The rule states that the measure of an arc is the same as its central angle. So look at this central angle here. Look at this angle GHF or FHG. This central angle here creates this arc right here on the circle. And if you notice, this central angle is 60 degrees. So if my central angle is 60 degrees, the arc that this central angle creates is also going to be 60 degrees because the central angle and the arc that it creates are always the same measure. Now take a look inside here. Do you notice anything about these two angles here? Do you notice that this diameter is a straight line? What do you notice about these two angles? Well, if you notice that they're a linear pair, that's a very good observation, meaning that these two angles together create a straight line. So, how many degrees are in a linear pair? Well, by now you should know it's 180. So if this is 60 degrees, can we figure out how many degrees there are here? Sure. 60 minus 180 is going to give us 120 degrees. So we can see here then that angle GHE is 120 degrees because these are a linear pair. And by the way, notice here, well, we'll get to that in a second. Notice here this diameter is a straight line. These are a linear pair. Together they make a straight line. Well, if this central angle here, GHE, is 120 degrees, well then how big is the arc that it creates? How big is the arc that it creates? Well, if you guessed 120 degrees, you guessed correctly again. Because this central angle is 120 degrees, then the arc that it creates is also 120 degrees. By the way, do you notice this diameter here? Notice this diameter cuts a circle in half? Well, how big is this part of the circle up here? How big is this arc, this whole arc right here? Well, do you notice this is also half of the circle? And we know that a half a circle or a semicircle should be how big? 180 degrees. So take a look at that. 120 plus 60 is also going to give me 180 degrees. Well, let's take a look here. Let's move on a little forward. Let's take a look at this circle here, circle R. Let's take a look at circle R. And let's see if we can name some parts of circle R. Let's say we wanted to name arc MN. How big is arc MN? Well, if you notice, the central angle, MRN right here, is 80 degrees. So if this central angle is 80 degrees, the arc that it creates is also going to be 80 degrees. So then arc MN is going to be 80 degrees. How big is arc MPN? MPN. Wow, well, let's take a look at that. From M to P to N. That's the rest of the circle. That is the completely, I know that this part is 80, but that's the rest of the circle. That's not 80 degrees. Well, how many degrees are there in a circle? Well, we said that there are 360 degrees in a circle. So if the whole circle is 360 and this part is 80, well, how much is the rest? Well, then all we have to do is 360 minus 80, and that's going to give us 360 minus 80 is going to give us 280 degrees. So the measure of arc MPN is going to be 280 degrees. How about the measure of arc PMN? PMN. Let's see, go from P to M to N. How about arc PMN? How big is that arc? PMN. Well, first of all, I hope you notice that it's a semicircle. It's half the circle. Because you notice here, here's a diameter, and the endpoints of the diameter make up arc PMN, which you know is going to be what? 180 degrees. So arc PMN is going to be 180 degrees. And that's our brief review